Hey guys, thanks for joining this episode. My name is Andy Parsons. I am a cloud architect based in Melbourne, Australia, with about 20 years in the business in systems engineering, various roles over the last 20 years. Prior to my current role at Pure Storage, worked for Facebook as a data center manager or data center architect managing global infrastructure. Today I focus on container technology, including Kubernetes, OpenShift, and everything in between. And in today's session, I want to talk about business continuity for Kubernetes. And I'd like to talk about a few things. First, why do you need this? Why do you need disaster recovery for applications? And what happens if you don't? What's the ramifications of not having it? And obviously we'll be specific towards stateful applications in Kubernetes. And I'd like to do a demo of taking a stateful application and failing it over from one Kubernetes cluster to another. We'll walk you through the life cycle of moving that application and its data and doing it in real time. So let's get into it. Why do we need disaster recovery for an application? Show of hands, who thinks that in the age of public cloud, you never need to think about DR again? Now, I always get different opinions here. Some people say yes, some people say no. Even in public cloud, all of the providers insist that you plan for multiple availability zones. And that's why they have them, right? So that should one fail, or we have a maintenance event or an outage, which happens, you can have continuance of that application. And moving to the public cloud, this is very easy to consume. But you still need to think about what's a disaster recovery plan, right? Nobody cares about what the infrastructure your application runs on if it goes down. If I can't check my bank balance, it makes no difference to me where it's running. So what happens if you forgo DR or you don't plan for it? This could cause excessive time to bringing an application back online. Maybe you've got to rebuild from scratch. Having to build new things on the fly, or not having a business continuity plan. This could lead to a loss of customers or revenue for the business. It could be a loss of brand value, right? Or even a loss of the company's ability to generate revenue. If your internal team can't access their systems. And when we think about, when I talk to customers about Kubernetes in disaster recovery, it's a very hot topic. And I think part of the reason is there's a gap left out when you consider stateful applications in Kubernetes. Now, when we think about DR for containers, this is probably what most of you think of, right? You've got Jenkins for config management. You've got your Artifactory for an image repository or some sort of image repo. It's probably mounted to an NFS server or an array somewhere. You've got Git for storing your code, and you can redeploy all of that with some sort of CI/CD pipeline. Now the problem is there's a gap when we think about stateful data, right? Now this gap can be covered in a myriad of ways, and if we look at this from, say, the infrastructure team's perspective, they probably leverage a CSI driver, maybe they consume some storage from an array, maybe they do a snapshot with like custom resource definition, and they can use array sync technology to replicate that to another cluster. Maybe they use Ansible or Terraform to automate this process. They can rehydrate that data and reattach it, right? Happy days, you've got CI/CD. And this is great. We built a DR system for a single application. Well, let me throw a wrench into that whole process. Okay, the business unit wants to add 20 more apps, all of which will be production. And the DevOps team member who built that DR system, he left 6 months ago. Now the security team, they want to upgrade the image repo and the version of Jenkins to the latest version of code. And your storage team is now doing an upgrade to at least to the latest array software. They say it'll make it faster, right? Now, how many moving parts do you have to your DR system that are not native to that application or to Kubernetes for that matter? And how does that application DR strategy change with the evolution of Ansible modules or Terraform or pick your automation framework? These are the questions that we need to ask ourselves when we build scalable DR solutions that can handle these workloads. Now, I want to talk about Portworx for a moment. Now, Portworx has built a system called PXDR, and it's application native, and it provides DR capability at the Kubernetes layer. It's actually a part of the DR system. or of the Portworx system rather. So this removes your dependencies on infrastructure or anything external to Kubernetes. So in this scenario, we're looking at a Synchronous DR cluster where we actually take two separate Kubernetes clusters. We stretch a storage fabric between them so we can replicate data in real time. So if, say, this application Elasticsearch is trying to perform a write to that volume, we will replicate the data on that volume in real time to a mirrored volume on the secondary site. We'll send an acknowledge back to that primary site before we ultimately update the client. And this is done in real time. So that data in that application always has a synchronization of data across two clusters. We'll also take all of the objects inside Kubernetes that are part of that application in the namespace. Could be deployments, could be services, it could be a secret, it could be config maps, and obviously the persistent volume data. So we'll replicate all of those objects to that cluster as well, and they will be stored in a state where they can be scaled up quickly. Now this is policy based, so I can schedule this on a policy, I can assign new namespaces to that policy, and I can say maybe I have DR, or maybe I have dev running on this cluster. I don't really care about that, but I only care about prod. All right, we might just replicate prod and leave everything else. And this can be moved from cluster A to cluster B, and in the loss of a cluster, and in the event that we restore that cluster, we can move that data right back to where it was. Neat thing about this is granular inside Kubernetes, so we're looking at Kubernetes objects, so there's nothing external. It's policy based, so modifying policies that run inside of Kubernetes at the Kubernetes API is how we will make changes or additions. And we can schedule that replication on the object. So we may not need to replicate, a secret every 30 seconds or maybe every minute. Maybe we want to do it once a day. Maybe we want to be concerned about, latency or the bandwidth on the link. So we can be very granular about how we do that. Now let me go into this environment that we've built and show you around. So I've actually built two clusters. These are both in AWS. So we've got Site A, which is effectively called Master 1, is how you'll see it, and then Site 2 or Master 2. These are both in the AWS region, Southeast region. And so we're going to deploy an application called Pet Clinic, which is just a WordPress app. It's got a WordPress front end or a web front end and a MySQL backend. We'll have some persistent data attached to that SQL backend. We'll show you the UI of that application. We'll write some data to it, and then we'll kill the cluster and we'll fail it over. And I'll show you that whole process. Now in the earlier slide, I showed you that single cluster. So we're actually going to deploy this storage cluster across the two, and we'll pair the two clusters so they can communicate and replicate data between the two of them to do that. And then we'll use a tool called Stork, which is an open source storage operator for Kubernetes that will allow the movement and replication of objects to and from these two clusters. So let's get into it. I'm going to open up the UI. Now, if I open up these two screens, you can see here I've got Master 1 and Master 2. If I do a kubectl get nodes, you'll see I've got two 4-node Kubernetes cluster. So I've got a master and I've got 3 workers. And if we do a kubectl get deployments.apps, you can see that on cluster 1 I've got an application called Pet Clinic with a deployment, a Pet Clinic deployment, which is the front end, and then a SQL deployment on the back end. On the left, you can see that it's deployed and up and available, and that's where we're actually serving workload today. And on the right, you can see this is an application that's actually scaled down, right? So the objects live in both of the clusters, but only one of them is serving I/O. I can do a kubectl get PVCs, and we can also see that we've got an 8 gig SQLDB volume in both sites. So you can see that they both have the same volume name and they have the same ID. They're using the same storage class as well. So that volume data is being replicated in real time. So when I make changes to that application, that volume data is automatically replicated to that volume, and an acknowledgement is sent right back. Now remember I said we use a tool called Stork. So I'm going to actually change this here. So Stork is a tool that we use for data replication. And this is what we use to pair these two clusters so that we can replicate and move objects between the two of them. I'll use Stork to take a look at the cluster status. And this will tell me the status of this application. So you can see I've got a cluster called Metro Cluster. I've got a local domain called Cluster 2. And then I've got a cluster domain called Cluster 1. Now this is obviously Cluster 2, which is a secondary site. And this is Cluster 1. And you can see they're in sync, so they're paired using Stork. And if I do a kubectl get pods -n kube system, we're going to actually take a look at Portworx under the hood. Oh, sorry, not kube system, Portworx. We'll see that we have a whole bunch of pods running that make up this cluster. So I said we've got 3 nodes on each cluster. You'll see there's a whole bunch of pods running here, and there's 3 of everything. So we've got some API pods, we've got our DR pods, we've got the CSI, and then Stork. All of these serve different purposes for management of data and objects on each of the clusters. What we'll actually do is we will log into one of these and run some storage commands. So to do that, we're going to do a kubectl exec, and I'm actually going to run some pxctl commands. These are commands where I interact with the Portworx storage system to just view the status, look at volumes and things like that. So we'll run that against this pod, and we'll just do opt/pwx/bin pxctl status -n Portworx. Oh, wrong pod. Let's try that again on the right pod. All right, so you can see I've actually got a Portworx cluster running with a single storage pool across all of these 6 nodes. So you can see nodes 1-1 through 3 and nodes 2-1 through 3. Right, so all of the 6 nodes in the cluster are participating in the storage cluster with about 20 gigs per node for a total combined capacity of 120 gigs. If we were to take a look at the volumes, we should see that 8 gig volume here as well. List. And there's that 8 gig volume that we spoke about. So that volume is being replicated. Now you notice it's got HA, so if I were to do a volume inspect that name, what I should see is that volume has actually got that data stretch across 2 nodes. Now, if I were to do a kubectl get pods or get nodes, we would see that one of these volumes, 101.103, is on cluster A, and the other is on cluster B. So that data lives on 2 separate storage nodes in 2 separate clusters. So that in the event of a failure, we can restart that application. All right. So let's go write some data on that application. All right, so what I'll do is I'll open up one of these nodes and we'll do a node port redirect on that application. So we'll do a kubectl get service. We should see pet clinic redirecting to port 30333. Now if I do a kubectl get nodes-o wide, that's going to give me the private address. So to get the public address, what we can just do is we can actually just hit any one of the nodes, or we can hit the master's public IP, and we'll redirect to that port. So we'll go ahead and do that. That brings up pet clinic. We can go in here, we can go into find owners. I can create some data. So I can add an owner, add a record, we'll call it Andy Parsons. And there we go. So that data has been written to the PetClinic database. Now if I go back in here to go find owners, should see we've got about 11 records total. So I've added this new record here. Right? So now that we've written that data, this data has been synced real time to the secondary cluster. So let's initiate a failure. Let's kill the cluster and bring this application back online on the secondary node. So what we'll do first is I'm going to do a watch kubectl get nodes, and we're going to watch the status of these three worker nodes. So to simulate that failure, what I'm actually going to do is kill those nodes. So I'll go back into the AWS UI, and I'm just going to select the 3 worker nodes running on that cluster, and I'm just going to stop those instances. Now while we wait for that to happen, we should see these go back to not ready here in a moment. And on the other cluster, what we'll do is do a kubectl get pods -n Portworx. A couple things are going to happen here. We're going to see when these cluster nodes go down, Portworx is actually going to go into a state where it's going to go, hey, what's going on? I'm not seeing the cluster. So we could probably first do a log into this and just do a pxctl status. All right, you can see a couple of the nodes starting to come offline. So we'll do a kubectl exec /opt/pwx/bin/pxctl status. Same command, -n Portworx. We should see these nodes, we should see it in a failed state, right? Not in quorum, because it's not seeing all of the nodes, right? So half this cluster is down. Now it's still, this cluster is still online because I'm still able to run this command, but it's seeing it as not in quorum, right? Because the primary site has lost 3 of those nodes. And if we do a get cluster domain status, I think we should see a not in sync. It still hasn't timed out yet. But what we want to do is break this connection, and we want to bring this cluster back online so that we can fail that application over. So to do that, what we're actually going to do is deactivate the cluster on this secondary site. That's going to tell Portworx that the cluster's down, so deactivate the domain cluster1, and this will tell the cluster that is down and mark it in a down state, and it will bring that cluster online so we can actually use that data that we've replicated. Right, so we'll deactivate that cluster, and in a moment we should be able to rerun this pxctl status command, and we should see this site come back online, and all of these nodes will once again show as active, and the unavailable nodes will show as offline. There we go. So now you can see these nodes are starting to come back up online. So we've got a couple of nodes that are up and a couple of nodes that are down. We'll give this a few moments here. And what we should see eventually is these 3 nodes down, and then we should see 3 nodes up. So online and up. So those nodes are back online. So now we have failed the cluster over. We've told the cluster that it is not available. Now let us bring the application over. So to do that, we're just going to use stork again to do a migration. So we'll do a stork-ctl activate migration. What that's going to do is it's going to scale this application back online into the site. So it's going to glue the application or those persistent volumes to the PetClinic app. Now this can be done, this is just activating a migration for this one application. There could be 100 applications in here, and this one command will fail all of those applications that are designated in all of those namespaces. So we can do a kubectl get pods, and we should see this come up and running here in just a moment. We'll let that go. So we've got the SQL backend running. Now we'll do a couple things. We'll do a kubectl get service. And we're right, PetClinic is redirecting on port 30333. Well, what we'll do is I'm going to refresh here. This should time out here in a moment because it's not serving I/O. This is that primary site. We will go back into the AWS UI and let us take a look at one of these nodes in the secondary cluster now. That's where we'll redirect that node port. So we'll go node 2-2, and I'm just going to pull one of these public IPs, and I'm going to pass that port. And voila, we have brought that application online onto that second cluster. Now let's see if the data that we wrote in that primary is still there or has been migrated. So we'll go to Find Owners. Remember, I added Andy Parsons, that new record. And we've added Andy, and now we've got all of the records that were in there plus the Andy Parsons. Now we might want to simulate, let's say that application, that primary cluster actually came back online. That cluster, maybe somebody unplugged the cable, maybe somebody made a change to an AWS, to a route, which just took the network down, and that since has been restored. So we want to bring that cluster back online and move that application back. So first, maybe we'll add some data. So a new record, we'll call it John Doe 1 Main Street, maybe in Singapore. Phone number, we'll just put some dummy data in here. I'm going to add a new record, and we'll go back in, and we can see that we've added John Doe. And we will go back to AWS, and we will bring those nodes back online to simulate that site coming back. So 1-1, 1-3, and 2 and 1-3, right? So we'll start those instances. You can see the site is down on the primary site, right? Because it's we had killed it. We should see these nodes come back online here in a few moments. All right, the nodes are the nodes have been restarted. The application is back online. Probably going to have a different public IP, so we'll just actually close that window up. And we'll see that come online in a moment. And a few things that we'll take a look at here. You know, looking back on the screen, we can see those nodes as marked as offline and down. So Stork has marked them offline and down. And you know, you can see on the left screen now these nodes have actually come back online. So we want to bring this cluster back into quorum. We want to say, hey, let's resync the data. We want to move that application back. And I'll show you how easy that is to do. So if we do a stork huddle get cluster domain status first, we should see that we're not in sync. So cluster domain 1 is not in sync, right? It's not seeing that data. Well, we want to tell it to. So what we'll do is we'll activate that cluster. So we'll just do an activate cluster domain 1. We'll tell Portworx, hey, this cluster is now online. Let's sync it now. So if I go back and do a cluster domain status, you'll see a sync in progress. So what's happening is that cluster is coming online, and it's going to sync that volume data. So, you know, all those writes, that new record that we just wrote, we're going to sync that back to the primary site. Probably run that one more time, and it should be in sync. It's not a lot of data. And we can also do a pxctl status, and we should see that all of those nodes are back online. Yep. So everything's back online, everything's up, everything's happy. So, you know, just like moving that application over, we'll do the similar process. So this could be a single application in a namespace. It could be multiple applications in multiple namespaces. All we're going to do is run this deactivate migration. So we're going to tell these two clusters, hey, deactivate the migration, scale the application back down to 0. So if I do a kubectl get pods, or actually we'll do deployments.apps, get deployments.apps. And you'll see that application is at a ready 0 state. So we've scaled it down. And if we were to do that same command on the primary side, you should see this application is now back online and running. So let's go to one of these nodes. The IPs probably all changed because they're just in AWS. So we'll go ahead and we'll copy that. We'll open up a new window. And let's open up Pet Clinic. So the application is now online. If I were to go look and find owners, we should see the data that we added in both the primary site and the secondary site, right? So we wrote data on primary, we moved the cluster with the data that was intact. We wrote some more data because the site still had to serve I/O, and now we want to bring it back. Right, so you can see that John Doe has been added, and all of the workload is now running on the primary cluster, and that's how you perform synchronous replication using Portworx across 2 Kubernetes clusters. I hope you found this useful, and thank you for watching.